Camera. Good. Here we go. There we go. Excellent. Alright, let's begin. So, what is mass? Let's say you guys wake up in the morning. When you wake up, aren't you guys hungry? Your stomach is empty, correct?
No, sir, because I eat at like 2 a.m. I go downstairs and eat some cereal.
For normal people, because Benjamin is different, because I don't eat at 2 in the morning. But for persons, in the morning you are Oh, cameras on, everybody. Cameras on. Cameras on. Cameras on for me, please and thank you. Benny, Alex, Yifang, and Zenodo, camera on for me.
Turn on your camera, turn it on.
There we go.
Alright, boss man, George, relax on the George, with Jesus.
Right. The only person that shouldn't have the camera on is Zenodo, and he explained why. So Yifang, camera on for me. There we go. Okay, let's continue. So in the mornings, your stomach is empty. Would you believe me if I told you that technically you weigh less, or you are less mass before you eat in the morning? Why?
Because I believe you, sir, because I would kind of understand that because I did it once and I wonder why did I weigh more before I eat than after I eat.
Right. So if you eat food, right, that's why you put on pound. So the next thing I want you to try, when it's lunchtime, before you eat the food, I want you to put it on a scale or put it on a weight and tell me how much pounds it is. Typically it's going to be between 1 and 2 pounds. So when you eat food, you actually put on a pound or 2, and then during the day when it's digested now, you lose that pound through either you burping, through either you yawning or farting, whatever. Alright, that's how mass works. So you typically, you are measured in mass, alright, and we're going to find out the units of mass. So before we know what the units of mass is, we must firstly know what is SI unit. Alright, yesterday we looked at length, and we know that the unit, the SI unit, right, it's something, the SI unit of length was meter. So what is SI unit? The SI unit of length was meter. Can you repeat that for me?
Simple or basic?
That's a great attempt. So SI unit, SI is an acronym, alright? It's from France. And SI really means International System. So it's a unit system that everybody in the world uses. If you go to Japan, they measure their lengths in meter. If you go to Jamaica, you are in Jamaica, we measure our lengths in meter. Alright? So it's the most widely used system in the world. Okay? Right up for me. The SI unit stands for International System. And you might be saying, sir, how can it stands for International System and the S comes before the I? Right.
Yes, sir.
Right. Let me explain why. The French created this system, right? And typically when you are creating an acronym in French, the words behind come first. Alright? So really and truly, we should say System International, but because it's French, the noun comes before the verb, so we say International System. So you'll understand what I mean when you're doing French. Alright? So that's why you see International System. Alright? It is the most widely used system. So any country, sorry, that's for me, which means that any country you visit.
Sir, do you mind zooming out a bit so I could?
There you go. That any country you visit would therefore use length to measure distance. But that doesn't mean that it's every country. Alright? Some countries uses something called the metric system. Sorry, another form of system. And we're going to learn the other forms of systems, such as the CGS system. So any country you visit may most likely uses this form of measurement. And put in bracket for me, length, for example, length, sorry, not length, meter and grams. Meter and grams. Okay. Everybody have that down?
No, sir. I'm writing it down quickly.
Alright. Quickly write it down for me. No. We learned that when we talk about meter and we had kilometer, what do we call meter therefore? It starts with B and it's a 4-letter word.
Basic unit.
Basic unit.
Right. It's a base unit. Alright? So grams is the next base unit you're going to learn today. So we learned that meter was a base unit, and we're going to learn today that grams is a base unit as well. Alright? So the base units...
So like kilogram, decigram, milligram.
Right.
So I learned some of them in grade 6, but I don't remember them fully.
Don't worry, we're going to go through it. So that's good. So you learned kilometer. For a meter, we have kilometer, right? Centimeter and millimeter. Now for grams, we're gonna have base units being for grams. Alright? For grams, we're gonna have kilogram, centigram and milligram. Okay? Alright. Now, that's the second unit we're going to learn. So, I'm on page 272 and I can send you the link to the book. If you still don't have it, just let me know. We're using all the different...
I don't have it.
Alright, let me send you the link to the book. 1 second. So, I'm going to upload it on the virtual notebook and you'll have the link to it. 1 moment. So here we go. Just upload /upload. 1 second.
So you can just simply just Control V.
1 second.
For the link.
Wait, can you repeat that?
Sir, if you copy the link, you just done Control V to paste it.
No. It's on my laptop. That's why I can't just Control C. But I'll send it after class. Just send me a reminder and I'll send you a link to it. Okay, so let's follow along with me now. Mass, the frequently used SI units of mass is going to be kilogram, gram, and centigram. So it's really the same idea behind meter. The only thing you're going to change is the suffix. So the prefix is kilo and centi, but the suffix, which is the end part of the word, is gram. So we change from meter to gram. So therefore, 1000 gram gives you 1 kilogram. It's the same idea. Alright, that's the first one we're going to write. The conversion table. The conversion table.
Sir, what did you say that we should write for mass? The definition that you should write for mass.
Okay, the definition you should write for mass. Here we go. So look here for me. Mass is the amount of matter in an object. The amount of matter in an object. Alright? Which is measured in the SI unit gram. So mass is the amount of matter in an object. Mass is the amount of matter in an object which is measured in the SI unit of grams. Okay, you're gonna put G for the symbol. Alright, now I know when you go on your scale, when you read it, does it say grams or does it say pounds?
Sir, mine is in pounds, sir, but I can switch it to grams if I want to.
Right. So that means that's another that's another system we use to measure mass. Alright? We use pounds. But for today we're gonna learn about grams. Okay. Now the same idea from yesterday, the conversion table. I'm gonna zoom in on it. Conversion table. To get 1 kilogram, How much is that equal to? I'm going to call on Aliana Walters. How much grams make 1 kilogram?
1,000 grams make 1 kilogram.
Right, 1,000 grams. I'm not finished yet. One moment. You have 2 more questions. How much? 1 second. Let me just check. Here we go. Okay, how much? Can you repeat that?
Sir, can I get this one?
Sure. All right. So this one says how much gram make, or how much centigram make 1 gram? 1 gram is equal to how much centigram?
So that would be
CG at the end.
CG, yes.
Think about it. So swap it with meter. 1 meter is equal to how much centimeters? Think about it. If I have X amount of centimeters, that would give me 1 meter. How much centimeters is it?
Sir, so it will be 100.
100. 100 centigrams would give you 1 gram. Alright? Let's look on the table. Sorry, 0.01. You will convert. Sorry, 0.01.
0.01.
Alright? So quickly look on the table for me. So 1 centigram is equal to 0.01 grams. I'm going to explain it for you. Let me check the waiting room. Okay, we have Jamie. Okay, good.
Hello, Jamie.
Alright, so write this out for me. 1 kilogram is equal to 1,000 grams, as Aliana said. And 1 centigram is equal to 0.01 grams. Or the other way around, 1 gram is equal to 100 centigrams, as George said. Alright? So I'm going to write it the other way around since that's what we're familiar with. Okay? So 1 gram is equal to 100 centigrams. Or the other way around, 1 centigram is equal to 0.01 grams.
Okay, sir.
Alright, but I'm going to ask one person to explain what did I do to get the other way around. I'm going to ask Benjamin.
Oh, sir. Oh.
Benjamin. Alright.
Sir, you didn't put my name. You didn't put my name.
Oh, my bad. My bad. George. There we go. Okay, Benjamin.
Yeah,
Yes,
boy.
sir.
If I have 1 gram that is equal to 100 centigrams, what operation do I do to find 1 centigram? Look at it closely. Let me zoom in for you. I have 1 gram. Wait, let me put it the other way around.
1 gram.
So let me put it right here. There you go. It's equal to 0.01 centigram. See, it's a very simple operation. You divide both sides by what to get 0.01?
Wait, divide both sides by what?
So if I have 1 gram here,
Oh, I know this. Okay, you would. Well, if you're on a piece of paper, you could move the point with a pencil and draw like little things. So what you could do.
let me draw it for you.
You could divide it by. I don't know how to explain it, but
So-
you would move the point.
So look at this.
That
So remember, you should
You
be
move it-
on the page. So you should be able to draw here for me. So you should be on the notebook and you can just draw here for me.
Sorry, I don't have the link.
Oh, let me send the link in the chat. But in the meanwhile, while you're going on the link, let me just draw what I think you're saying. So there's the link. Okay. All right. Now look at this for me now. If I have 1 gram, which is equal to 100 centigrams, right? Couldn't I divide both sides?
Yes, yeah, you could move the point two spaces to the left.
So that's 1.
So I think that would be dividing by 100.
Dividing by 100. So the decimal point would be now here. I'll put a 0 right there. So we'll say 0.01 grams is equal to. We'll just move this 2 spaces as well. 1. centigram. Alright? So you divide both sides by 100. Alright? Okay. So that's a quick little sketch of explaining what Benjamin just said. Good job, Benjamin. Okay. Now the next one, I think Benjamin's name is there. Let's go to the last one. We're going to deal with milligrams now. Okay. Now for this one, we have 1 milligram. But I want to know how much milligrams gives me 1 gram. This one goes to Isabel. Isabella, how much milligrams give me 1 gram? To make it better for you, you can just swap it with meter and then you just put back the correct units. So how much millimeters make 1 meter?
1,000.
1,000. So you're going to say 1,000 centigrams is equal to 1 gram. But you're not finished yet. How much would 1 milligram be? So if I have 1 milligram, how much would that be in grams?
That will be point something something.
Right, it has to be smaller. Right. But what would I do, Isabel?
Divide.
Divide by 1,000.
Right.
Which would you
So I divide.
0.001.
So 0.001 grams is equal to 1 milligram. So we see a trend happening. All right. If you're converting from, it's the same trend that we saw for meter. Right. When you're converting from larger to smaller, do you multiply or divide? This one goes to Naima. Remember, I went through with you yesterday, Naima. If you're going from larger to smaller, alright, do you multiply or divide?
You multiply.
Let's check it again. So we had 1 gram and we wanted to know how much milligram that was. So we had to get larger or smaller. You said multiply. Is that correct, everybody?
No, so you have to divide.
Right. So if I have smaller, right, in order to get larger, I must divide. And if I have larger, in order to get smaller, right, I do the opposite. But let me go through some examples for you quickly. Let's convert all of these that we just did into laws of indices. So put this for me. Using laws of indices to express units. Okay. 1 second. Let me just put this above. There we go. Okay. Now for the first one, we can express kilogram. We can express kilogram as a power of 10. Okay? Somebody remind me, how much did 1 kilogram equal to?
1,000 grams.
1,000 grams. So, how many zeros do you see at the end here?
We see 3 zeros.
Right, so we can say therefore 1 kilogram is equal to 10 to the 3rd power of grams. Right off for me, everybody. 10 to the 3rd power grams. Okay. There we go. The next one, let's do one more. We have centigram. Okay? We want to know how much did 1 centigram equal in grams. So we said grams is equal to 1 centigrams. We must have divided by 100. So therefore we got 0.01 grams. Alright? Now, I want somebody to express this now as a law of indices. what would be the power of 10 of 0.01? One person? How would you express 0.01?
10 to the negative 4.
10 to the negative 2, is that what you said?
Yes, I'm not sure.
Alright, let's check it. So, firstly, let's write the number. 10 to the negative 2. My bad. 10 to the negative 2. 1 second. There we go. Oops. 10. Yeah, there we go. So 10 to the negative 2 would simply be, let's check it. Yes, it would, because it means, therefore, you would go 2 spaces, you move the decimal places twice, and that would give you a smaller value than 10. So 0.01 is the same thing as saying 10 to the negative 2. Alright? So 10 to the negative 2 equals 1 centigram. Okay, now for your homework, I'm going to give you the rest to do. You're going to convert for me milligram and microgram. So, convert milligram and microgram in the following as powers of 10 rather, as powers of 10. So, first one, let me show you. 1 milligram is equal to 0.001 gram. Convert that to a power of 10. So 1 milligram is equal to 0.001 gram. What would that be as a power of 10? And 1 microgram is equal to 0.00. Let me write it off. 1 microgram is equal to 0.000001 gram. What would that be as a power of 10? So first homework, I'm going to put hashtag homework. Okay, good. Now, for the next section, here's what we're going to do. We're going to learn of the other units that are on the SI table, or the Significant International System table. So we know we have kilo, we know we have centi, but we're going to introduce to you micro, mega, and etc. That rhymed. Okay, so look at this table for me, everybody. Let me scroll up for you. Here we go. So you're not required to know all of them. I'm just going to indicate the ones that you should know. Right? Micro, milli, centi, deci, deca, hecto, kilo, mega, and giga. Those are the ones that you are required to know. So I'm going to copy the table, and I want you to take it off in your notebook. Alright, let me copy the table. Here we go. So I want you to be able to recall these units, and these will come back on your test. So let's go through them quickly. Let me paste it here. Upload. Alright, now let's go to the first one. Nano. See, you might have thought I would say giga is the first one, but the first one is always going to be the small ones. So nano is the smallest one on this table, and it has a value of 10 to the negative 9. Alright, so whenever you hear nano, the prefix means 10 to the negative 9. Micro means 10 to the negative 6. Alright, milli, you know already, is 10 to the negative 3. Centi is 10 to the negative 2. Deci, 10 to the negative 1. Deca, 10 to the 1. Hecto, 10 to the 2. And kilo, so that's why you say that 1,000 meter would give you 1 kilometer, because kilo is 10 to the 3. Alright, mega is 10 to the 6, and giga is 10 to the 9. So each of them increment by 3, but then now when you're decreasing from 3, you go 3, 2, 1, negative 1, negative 2, negative 3, negative 6, negative 9. So here's what I'm going to do to help you practice this. Alright? You're going to do these conversions for me now. We're going to practice them together. So it says, using indices, convert the following measurements. We have 2.5 times 10 to the negative 3 kilometers to millimeters. So let me write that question.
Sir, can you please go back to the homework?
Sure.
I want to.
Here's homework. Convert milligram and microgram in the following as powers of 10. So if I told you that 1 milligram is equal to 0.001 gram, what would this value be as a power of 10? Same thing for microgram. Okay? Now, using this table, we're going to practice some questions for classwork. So here's the first questions. We're going to do 3 and 4 together. It says, convert these measurements and express your answer in standard form. First of all, let's go back over standard form. Let me just express it right here. Standard form. Alright, who can recall what is standard form? Question sign.
Express with powers.
Alright, so give me an example, right? Give me an example of a standard form. So let's say I had a number. How could I use standard form to express that number?
10 to the something power.
Right, 1 second. So would this be an example of a standard form? 10 to the 2, which would be 100?
Yes, I think.
Alright, so let's go through it together. So what I want you to do, firstly, you're going to write off question A for me. 0.005 kilometers to millimeters. Right? So first one, 450 centimeters to millimeters. 48.8 centimeters to kilometer. And finally, 0.0023 millimeters to centimeters. Okay. Alright. So, standard form is a very simple way of writing large or small numbers. So this was from Senior 1. Standard form is a very simple way of writing very large numbers or very small number. So let's say that the size of Earth was 10 to the 8. Somebody write out this number for me and tell me how large it is. So let's pick on, let's see who is here. Jamie. Jamie, are you there? Jamie, can you hear me? The size of the Earth is 10 to the 8. Write out this number. Alright, so I want one person to help me, and I want Jamie Lee. Is Jamie Lee there? Alright, Alex, camera on for me. Alright, I'm going to do some road checking. Jude, camera on. I see you. Yifeng, camera on. There we go. So since Jamie Lee is not here, I'm going to place her in a waiting room. Message me once you're back. Alright, let's check Alex. Alex, are you there? Alex, can you hear me?
Yeah, we can see him, but he's not talking.
Alright, I'm going to place him in the waiting room until he's back.
Sir, he is there.
Oh, he's there. Okay, he's there. Let's see. Jude. Jude, I want to hear from you now. Jude, are you there?
Yes, sir, I'm here.
Alright, good. So, the size of the earth is 10 to the 8. Alright? They want us to write out this number because it's a very large number. How would I write out 10 to the 8?
So multiply 10 by itself 8 times.
Right.
So
10. Oh, yeah, so a simple way of doing it is just to multiply 10 by itself 8 times. And when we do that now, how many zeros would I have at the end?
8
8.
zeros.
So let's do that. 1, 2, 3, 4, 5, 6, 7, 8. There we go. This is such a large number. Let's see if we can try to pronounce it. So let's put a comma each time at 3. 1, 2, 3. Now say this number for me. So
10 million.
So it's 100 million. 100 million, right? So the Earth is 100 million meters, for example. All right, and an easy way of
Earth larger than that?
yeah, it is larger than that. This is an example, though. All right, let me give you another example to say how small something can be. Let's say the size of an atom is 10 to the negative 8. 10 to the negative 8. Write out this number. And this question goes to, quickly, I want to hear from, let me admit you back now. Michael. Michael, are you there? Yes, Michael, can you hear me? Right. So, if a while ago when we had 10 to the 8, we put 8 zeros after the 1, where do you think I'm going to put the 8 zeros now? Before or after? Since it's negative.
Before, sir.
Before. So let's put that. 1, 2, 3, 4, 5, 6, 7, 8. And let's put the decimal point after. So that means that the size of an atom is so small, right? You're going to say it is 0.00000001 meter. That's so small.
8 zeros?
Can you repeat?
Is that 8 zeros?
Let's count it. 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8 zeros. Okay?
How?
Wait, what? That's the size of an atom?
Yeah, it's even smaller. What
I feel
is...
like that's bigger than it should be.
Yeah, a size of an atom is very small.
Sir, can you show me how you get 8 zeros?
Alright, 1 second. So the size of an atom is somewhere between 1 times 10 to the negative 10. So I was very close. Alright? It's 10 to the negative 10. Okay. Now, to explain how I got this answer, what happened? Alright, welcome back everybody. Now, quickly to answer Isabel's question, right? To explain how I got that answer, look at this one, Isabel. Alright. Look at this one now. Let's say that overall, I wanted to convert this number of 10 to the negative 8. So let me draw it right here. Look at this one now. 10 to the negative 8 to the negative 8 really means, pay attention for me, let's put it here, that I am going to move this decimal point 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. And each time that it jumped, I'm going to put a 0 as its placeholder. So I'm going to put a 0 right here.
But I would only have 7 zeros, not 8.
Let's check it. 1, 2, 3, 4, 5, 6, 7, and the place holded one more. So there we go. So my bad, 7 zeros, and it jumped one more space to make it 8. Alright, so that's an example to show you how small these numbers would be. Alright, now for a quick activity, that was to recall standard form. Alright, so what I want you to understand now is now that we know that standard form really means that we have very small numbers, alright, or very large numbers being expressed to a power of 10, right? I want you to try to convert now these numbers. We have Michael, Lima, there we go. I wanted to.
We have more minutes until class is done.
Yeah, no worries. So we're gonna try to attempt question 3, alright, and question 4 for homework. Alright. Now, because I had some technical difficulties, I'm going to record myself going through question 4, and that should give you the comfort now to attempt question 3 by yourself. Understood, everybody?
Yes, sir.
Alright. So have a great day, everybody. Apologies for the Wi-Fi connection. And just remember the homework you can start to do before I post the video. So let me show you the homework again. You're going to quickly convert, scroll down, 1 milligram, put the amount of grams as a power of 10, and 1 microgram. Alright? Understood, everybody?
Yes, sir.
Alright. Take care, everybody. Have a great lunch. Have a great break, I mean.